Its solid core stretches over 30 kilometers wide, dwarfing its predecessors. When it was first detected, it was racing through the solar system at nearly 58 kilometers per second. That's about 130,000 miles per hour, making it not just the largest, but also the fastest of the three interstellar visitors we've ever seen. The object's trajectory traced a steep path, arriving from the direction of Sagittarius and set to depart toward Gemini. Early calculations placed its origin in the thick disk of our galaxy, hinting at a birthplace among ancient stars far removed from the Sun's neighborhood. Its high vertical velocity relative to the galactic plane suggested it had been traveling for eons before crossing paths with our solar system. What made 3I Atlas truly impossible to ignore was the combination of its sheer scale and the timing of its arrival. Only 8 years had passed since the first interstellar object was spotted. And now, in rapid succession, astronomers were facing a new arrival that was orders of magnitude more massive. This frequency and scale defied all expectations. According to our current models, such large interstellar debris should be exceedingly rare, perhaps appearing once in many millennia, not twice in a single decade. Within days of its discovery, observatories worldwide turned their instruments toward the newcomer. Its brightness, mass, and speed all pointed to something extraordinary. Were our current theories about interstellar debris missing something fundamental? Before anyone could speculate about its true nature, the sheer improbability of its arrival demanded a closer, systematic look at every anomaly it presented. Each observed anomaly is assigned a probability, how likely it would be to see that specific feature if 3I Atlas were just a natural comet. Minor anomalies are unusual but not unheard of and are given probabilities under 10%. This framework allows us to systematically break down just how bizarre this object truly is. Let's start with the minor anomalies. First, there's its rotation. The light curve of 3I Atlas shows it's tumbling with a period of about 1.4 hours, which is incredibly fast for an object of its size. For a natural comet, spinning this quickly would create immense centrifugal force, likely causing it to break apart. While not impossible, it's highly unusual. Another minor anomaly is its brightness. It was about 10 times brighter than a typical comet of its size, suggesting it was either highly reflective or had an unusually large coma, the fuzzy envelope of gas and dust surrounding it. While strange, both of these features have been observed in other comets, so they fall into the unusual but plausible category. Now, let's move on to the medium anomalies. One of the most striking is its composition. Spectroscopic analysis revealed that the object's coma contained elements like iron, nickel, and titanium. These are heavy, industrial metals, not what you typically expect to find in a comet's icy makeup. Comets are usually rich in water ice, carbon dioxide, and other volatile compounds. While metallic elements can exist in cosmic bodies, seeing them in such abundance and flaring out into the coma is exceptionally rare. but 3I Atlas displayed jets that were pointed asterisk towards asterisk the Sun. This defies our fundamental understanding of cometary physics. The force pushing the jets should come from the Sun's energy, directing them outward. A forward-facing jet implies some internal energy source, or a propulsion mechanism, actively pushing against the solar wind. This behavior has never been observed in any natural comet. The third, and perhaps most significant, major anomaly is the sheer improbability of its existence in the first place. The timing of its arrival, just a few years after Oumuamua and Borisov, creates a statistical nightmare. Given our current understanding of the density of interstellar objects, the odds of seeing 3 such objects, with one being a massive outlier, in less than a decade are astronomically low. Some calculations put the probability at less than 1 in a trillion. When you combine this with the orbital alignment, the forward-facing jets, and the metallic composition, the argument for a purely natural origin starts to weaken significantly. So, when we put it all together using Loeb's framework, what do we have? We have a series of anomalies, each one unlikely on its own. But when you multiply these probabilities together, the chances of a natural object exhibiting all these features simultaneously become infinitesimally small. It forces us to ask a difficult question. If it's not a natural comet, then what is it? This is where the conversation moves from observation to speculation, and it's a path that science walks with great caution. The principle of Occam's razor tells us to prefer the simplest explanation. For many astronomers, the simplest explanation is that our models of comets and interstellar space are incomplete. Perhaps there's a class of massive, metallic comets forged in unique stellar environments that we've never encountered before. Maybe there are gravitational dynamics we don't fully understand that can channel interstellar objects into such precise trajectories. These are valid scientific hypotheses that need to be explored. However, there's another possibility, one that Avi Loeb and a minority of scientists are willing to consider. What if the simplest explanation isn't a natural one? What if the object's features, its massive size, its precise trajectory, its forward-facing jets, and its industrial composition are not coincidences at all? What if they are signs of design? The idea of an extraterrestrial probe is, for most, a line that science is not yet ready to cross. It invokes science fiction and carries a heavy burden of proof. Extraordinary claims require extraordinary evidence, and right now all we have are anomalies and probabilities. The story of 3I Atlas is far from over. Future observations from telescopes like the James Webb Space Telescope could provide definitive answers about its composition and behavior. We might find a perfectly natural, albeit mind-boggling explanation for all its quirks. We might discover that our galaxy is filled with a bizarre menagerie of objects that we only just beginning to catalog. Or we might find that the evidence continues to point in a direction that challenges our place in the cosmos. For now, 3I Atlas remains a profound mystery. It's a messenger from the stars, but the message it carries is written in a language we don't yet understand. It serves as a powerful reminder that the universe is far stranger and more wonderful than we can imagine, and that the next great discovery could be hiding in plain sight, waiting for us to look up and ask the right questions. Avi Loeb's framework for analyzing strange objects in space borrows its logic from risk analysis and forensic science. The core idea is all about independence. You find out by multiplying their individual probabilities. Finally, there are minor anomalies with probabilities under 10%. The odds of a random object from deep space matching Jupiter's solar radius so closely are incredibly low. What makes this geometry even more striking is that Atlas didn't start out on this precise trajectory. It challenges our assumptions about what is possible in the cosmos and invites us to consider possibilities that might once have seemed like science fiction. The mystery of Atlas is a perfect example of how science moves forward. It's not about having all the answers. It's about asking the right questions and being open to where the evidence leads, no matter how strange the destination. They say seeing is believing, but what if what we're seeing defies belief? For decades, we've scanned the heavens, searching for a sign, any sign, that we are not alone. We found whispers in the static like the famous wow signal and fleeting visitors from beyond our solar system like Oumuamua and Borisov. But now something new has entered our cosmic neighborhood. Something so strange, so massive, and so statistically improbable that it forces us to question everything we thought we knew about the universe. This is the story of 3I Atlas, the interstellar visitor that just doesn't add up. Our story begins with size. 3I Atlas is not just another piece of space rock. It's the largest interstellar visitor we've ever detected. To put it in perspective, it's 1,000,000 times more massive than Oumuamua and 1,000 times heavier than the comet Borisov. Think about that. According to all our models of how solar systems form and eject debris, giants like this should be incredibly rare. We expect to see countless small fragments for every single colossal one. So to have an object of this scale show up so soon after the last two is jarring. The odds are less than 1 in 1,000. Some might argue our telescopes are just getting better, and that's why we're seeing more. But better technology doesn't explain the sheer, unprecedented mass of this thing. The math just doesn't work. Each new discovery, each anomaly, makes it harder and harder to write this off as just a cosmic coincidence. The numbers are stacking up, and they're pointing towards something extraordinary. Every comet has a tail, a beautiful poem of dust and gas pushed away from the sun by solar wind and radiation. It's basic physics. But 3I Atlas seems to have missed that memo. Astronomers tracking its approach noticed something bizarre: a persistent jet of material not streaming away from the sun, but pointing directly towards it. A sunward jet. This runs counter to everything we know. As if that wasn't strange enough, high-resolution images revealed a concentrated glow, like a headlight shining in the direction the object was traveling. Some scientists try to explain it away as an optical illusion, a trick of the light caused by its speed or our viewing angle. But the jet and the forward-facing glow have remained stable across multiple observations. They refuse to fit into our neat little box of cometary behavior. Then we looked at what it was made of, and the mystery only deepened. Spectroscopy, the science of analyzing light to determine chemical composition, gave us another shock. The gas coming off 3I Atlas contains a ratio of nickel to iron that is completely off the charts. We've catalogued thousands of comets, and not a single one comes close to this. In fact, the plume is so incredibly rich in nickel that its chemical signature looks more like an engineered metal alloy than anything found in nature. The amount of nickel dominates over iron by a margin that metallurgists would recognize in a lab, but is totally foreign to planetary scientists. The statistical probability of a natural comet having this extreme composition is less than 0.1%. Sure, defenders of a natural origin say interstellar comets could just be chemically different from our local ones. But these numbers stretch that defense to its breaking point. Let's talk about its path through our solar system. The orbit of 3I Atlas is a puzzle in itself. It's moving in a retrograde path, meaning it's traveling against the flow of all the major planets. But here's the truly weird part. Its orbital plane is astonishingly flat. It's moving within about 5 degrees of the ecliptic, the very same disk in which Earth and all the other planets travel. For a random visitor from deep space, this is an incredibly rare alignment. Think of it like throwing a frisbee into a spinning merry-go-round. You'd expect it to slice through at any random angle. The odds of it entering and perfectly mirroring the plane of the merry-go-round, just going the opposite way, are minuscule. For 3I Atlas, the odds are estimated at just 2 in 1,000. So we have sunward jets defying physics, industrial-grade nickel in its plume, and an orbit that's both backward and perfectly aligned. These aren't just isolated quirks. They span physics, chemistry, and orbital dynamics. And with every new piece of data, the case for this being a normal, natural comet gets weaker and weaker. Now, let's connect some dots. Remember the WOW signal? In 1977, a powerful narrowband radio burst from the direction of the constellation Sagittarius, stunned astronomers. It lasted 72 seconds, was never repeated, and remains one of the greatest unsolved mysteries in the search for extraterrestrial intelligence. Well, almost 50 years later, 3I Atlas arrives in our solar system from a region of the sky just 9 degrees away from where that signal originated. Out of the entire 360-degree sphere of the sky, what are the odds of that? Statistically, about 0.6%. A slim chance. For many, it's just a spooky coincidence, a fun piece of trivia. But for others, it's a detail that sends a shiver down the spine. A detail that's hard to ignore. The final piece of this puzzle comes from the light itself. As telescopes tracked 3I Atlas, astronomers measured the polarization of the light scattering from its dust and gas. Polarization tells us about the physical properties of the material reflecting the light. And once again, 3I Atlas broke the mold. Instead of matching the polarization patterns we've seen in thousands of comets, it showed an extreme and unusual signature. Even our other interstellar visitor, 2I Borisov, was nowhere near this strange optically. The probability of this kind of polarization occurring naturally is less than 1%. Some SETI researchers have pointed out this incredible intersection of anomalies, a shared origin direction with our most famous potential alien signal, and an optical signature unlike anything we've ever seen. It's a rare convergence of history and physics. So what is 3I Atlas? A statistical freak of nature, a 1 in a billion comet that just happens to break all the rules of physics, chemistry, and orbital mechanics at once? Or is it something else? The data keeps coming in and the questions keep piling up. For now, it remains an enigma, a silent traveler from the stars, leaving a trail of mystery in its wake. And we are left to wonder, to watch, and to wait for the next clue. The nucleus of 3I Atlas is spinning, completing a rotation every 16 hours. On a natural comet, any vents or geysers would wobble and spray in different directions as the body turns, like a sprinkler head. But the jets on 3I Atlas are locked in a single, steady direction. For over 1 million kilometers of travel, they've held their course without wavering. This behavior is incredibly difficult to reconcile with random natural vents. It's far more reminiscent of controlled, directional thrusters designed to provide constant, stable acceleration. They're pushing the object, not just spraying randomly into space. And here's the kicker. Despite this immense, continuous thrust and violent outgassing, the nucleus shows no signs of falling apart. Standard comets are fragile. When they experience this level of activity, they tend to fragment, shed huge chunks of mass, or even disintegrate entirely. We've seen it happen many times. Yet 3I Atlas keeps accelerating under forces that should be tearing it to shreds, without a trace of catastrophic damage. It is holding together with a structural integrity that seems to defy the very nature of a comet. We need to measure the composition and speed of the material being ejected with pinpoint accuracy. Only that kind of hard data can tell us if this outgassing matches any known natural process, or we're witnessing something entirely new. Of course, there's a healthy dose of skepticism in the scientific community, and that's a good thing. Critics urge caution. They argue that multiplying probabilities like this assumes each anomaly is completely independent, a claim that is hard to prove when we've only seen a handful of interstellar objects up close. They also bring up selection bias. We are naturally more likely to spot and study the brightest, weirdest objects that pass through our solar system. The boring, average ones might just fly by unnoticed. Perhaps they argue, as we catalog more of these interstellar visitors, the range of normal behavior will expand. What seems extraordinary today might just become a new category of routine tomorrow. The debate isn't about whether 3I Atlas is strange. Everyone agrees on that. The real question is, how strange is strange enough to demand a completely new explanation? Where is the line between a very unusual natural object and something else entirely? Until those decisive spectroscopic tests are performed, the question will remain open. But the math, the sheer statistical improbability of it all, keeps pressing for an answer. Right now, as you watch this, telescopes all over the world are locked onto 3I Atlas. They are tracking an object that defies every reliable model astronomers have. Each new piece of data seems to stack more pressure on our fundamental assumptions about what drifts in the vast dark emptiness between the stars. As 3I Atlas continues its journey, now approaching the orbit of Jupiter, the need for that direct evidence grows more urgent with every passing day. Science thrives on outliers, on the data points that don't fit the curve. They are the breadcrumbs that lead to discovery. And when the odds scream that we should be paying attention, we have an obligation to look. What would it mean for humanity, for our place in the cosmos, if this time nature isn't the only author of the story? Thanks for watching. If you find these cosmic mysteries as fascinating as I do, be sure to subscribe and hit that bell icon so you won't miss our next deep dive. What do you think is going on with 3I Atlas? Let me know your theories in the comments below. See you next time.